welcome to 6.5, Examples A and B. So expanded form helps you understand many properties of exponents. It also helps you to understand how the properties work together. So use properties of exponents to rewrite each expression. So I have 6 times x to the 9th, so I'm going to rewrite that as 6x 2, 3, 4, 5, 6, 7, 8, 9 divided by 5x to the 1, 2, 3, 4. Alright, so now I can see this as several ways. I can just cross out each x individually, that's fine. Or I can cross out 1, 2, 3, 4 of them, and 1, 2, 3, 4 of them. Because if I multiply x 4 times and multiply x 4 times, I know that those two things should be exactly the same. And I will end up with just the 6 and the 5. No, I can't do it. It's not like I'm subtracting the 6 and the 5. Those are just two numbers. Is there anything that goes into both 6 and 5? Well, there is not, so it's just going to be a 6. I've got 1, 2, 3, 4, 5 left. X to the 5th over 5. If you want to write that as 6/5 x to the 5th, that also works. So we're just really using property of division, where if I have the same bases, I'm subtracting the exponents. So there's the first one, and I'm just going to move this a little bit over so I have some space. Alright, so I have 3x squared, 8x to the 4th, negative 4x cubed. So I've got a 3x times 8, 1, 2, 3, 4, and I'm dividing that by negative 4x. Okay, so I can kind of rearrange a lot of the stuff. 3 times 8, right? I can put the 8, I can swap those two, so I get a 3 times 8, and then I have 1, 2, 3, 4, 5, 6 x's. So I'm just write x to the 6th divided by, I've got this, negative 4x cubed still. Alright, so I just really did just the top first. Is that okay to do? Sure. And I've got 3 times 8, 8 times 3 is 24 divided by negative 4. So I've got 24 divided by negative 4, and I've got x to the 6th divided by x to the 3rd. Well, can I just do what we did in the last one without expanding it out? Sure, if I have the same base, subtract the exponents, that's going to be x to the 3rd. Alright, but now, can I reduce 24 and negative 4? I can. 24 divided by negative 4 is going to be negative 6. So that whole thing should be negative 6x cubed. And there is our solution for this one. Alright, and I'll do this last one in blue. Alright, just so we see it. So 7.5 times 10 to the 8th divided by 1.5 times 10 to the 3rd. So that really means I have 7.5 over 1.5 times 10/8 divided by 3/8. Well, can I just do this whole thing all at one time? Base is the same, 8 minus 3. I get times 10 to the 5th. Alright, so 7.5 divided by 1.5, can I do that? Yes, because think about minutes, 15 minutes and 75 minutes, 15 minutes goes into 60 minutes, 4 times, and that's another 15-minute segment, so it really should just be 5 times 10 to the 5th. And is this still in scientific notation? It is, so I am good. Now we go on to the next part. This investigation and example have introduced the division property of exponents. So for any non-zero value b of any integer, that means any non-zero value b and any integer values of m and n. So that means they have to be positive or negative whole numbers, right? No 2.3, 8.1, anything like that. B to the n divided by b to the m equals b to the n minus m. Hopefully a lot of you are saying, yep, I think I got that already. Great. Good. So now let's do another example. 6 years ago, Anne bought a van for $18,500 for her flower delivery service. Based on the price of similar used vans, she estimates a rate of depreciation of 9% each year. How much is the van worth now? Alright, so what we're going to do is we are going to take 18,500, and this is for part A, and we need to multiply that by something. Well, I know that the formula is A1 plus R to the T, or something like that. But now it's not going to be plus, right? Because it's depreciating. It's going down in value. Cars lose value. So it's going to be 1 minus 0.09. And then we're going to say, how much is the van worth now? Well, we knew that it was 6 years ago she bought it for this much. That means we're going to put it to the 6th power. And then if you plug that into your calculator, you should get an answer of $10,505.58. So that's how much the van is worth now. So now for part B, how much is it worth last year? We could say this is 18,500 times what it's worth now, 1 minus 0.09 to the 6th, and we just have to go back 1 year, which is take off one of these. We're going to remove 1 minus 0.09 to the 1st, right? Now, last year, we would just remove it once, or you could also write this as 18,500 as 1 minus 0.09 to the 5th. And that's not a number anyone really wants to know. If they say, is that how much your car's worth? They're going to look at you like you're crazy. So you should say $11,544.59. Okay, so then part C, we're going to do the exact same thing. The only difference is instead of minus or dividing by this to the first power, divide by this to the second power, which if I have the same bases, I can subtract the exponent. So 6 minus 2 is going to give me 4. So I have 18,500 times 1 minus 0.09 to the 4th. And when I plug that into the calculator, I should get $12,686. $12,686.37. Okay, notice how when we're going back in time, this amount is going up, right? 10,500, 11,500, 12,600. That makes sense to me because we're getting, years ago, the car was worth more money. All right, so there you go. There is examples A and B.